Oh, I don't wait for what? No.
So you won't recognize her.
Oh, really? No, not you.
It's actually.
There you go, because it's the same thing.
Did you go to this person? Oh my god.
No, this weekend was
She's driving me
Who
now.
was?
I respect you, like, how much more
We get. Yo, Jackson at the same place, bro.
I'm not.
Me and Jackson.
Yeah, I know.
But he doesn't have an ass. It's like. Dude, just see why you always
His loss, bro.
Sorry, Asian. Why are you doing this? So, like, I got Did you, bro? No, you just stated that you did it.
I'm not tall, but I'm tall.
Oh, yeah.
I can always teach
From like,
I don't even know what this is. This is like some equation to.
about your football picture, it looks like you're like 5'4".
This is calculus. So, I don't know. Dude, you shouldn't have put 5'11", dude.
Why is it 5'11"?
Oh, 5'11's like insane.
Like, have you seen that TikTok? It was like 5'11", you get in the shower, and it's like going up. Like, turn off the shower for like shower heads and
Invite me on the weekend.
you can't live in my house. Fresh, do you see him?
Wow. I am impressed. Okay, so how many were absent Friday to basketball and stuff? Hands up. 1, 2, 3, 4, 5. So 4 of you actually got on and looked. Is that you, Aiden?
No.
What about you, Enrique?
No.
Okay. What was my comment right after the last test? I had 3 categories.
You had
You are a
people who
Did okay.
did okay and tried hard.
Did well and tried hard.
People that was easy.
Well,
And then
And people that
people
just
that
suck at
like
not well, but still worked hard. Right?
Yeah.
Well and worked hard, not well, but still worked hard. And then,
blew it off.
yep, blew it off. How long? Yep, how long? Human beings are basically creatures of habit. You try to change something. Go try to change some behavior. You're going to find probably number 1, you're kind of addicted to that behavior because you're so used to using it. When you take it away, it gets freaky. Try to change the behavior. If you didn't get freaked out over it, it's still a lot of work because, yeah, you know, that's why the New Year's resolution, oh yeah, I'm going to change. Yeah, right. Come back to me in 3 months, tell me how that went. Because by 3 months gone by, your habitual programming has overridden the system. Okay? You're going to change habit. It means you're going to change physically your body. And what part of your body you're going to change physically is this map of it. You got to remap it to get those habits to change. That make sense? You don't remap it. Who runs the show is up here, right? So he's running the show. He's not going to change. So you're developing a habit. Well, you can say, well, yeah, but in the real world, I don't. Yes, you do. Okay? So, just think on that. It can be done, but it's not easy. It's going to Of course, you got want to first. And that's the hardest part. How the hell do I want to do this? Okay. All right, so today we're going to start out with, it's probably going to be easiest if you do get your computers out. Okay. All right, let's go back. So go to your Google Classroom. Go to classwork. All right. So in the text, well, what? You threw me out earlier today. Things seem to keep throwing me out.
So I click on it. Stream, that's not crash.
So open the test practice. You're going to work on the first one. So you want to pose this one up. Interpreting functions, FIAB. So get out a piece of paper because you're going to turn this in eventually. I'm going to give you some time right now. And so get out a piece of paper and treat this as a homework. So we're going to turn it in slightly different from the regular homework. And start working on them. So I'm going to give you 15 minutes to go work on those. All right? Okay.
Do we name it something? Like
yeah, that's a nice question. I like that question. Let's call it interpreting function for now.
We're using the backslash. We have to like see which function works for the sequence of the thing. Really? Yeah. Things like that. Did you pick one of these? So you're like plugging it in and finding like next signals, right? Yeah.
What?
I think it might be the last one.
So they're all no,
Did you get it? So I think it's either.
All right, come on, work on the problems. Or we can move on and have you do them tonight.
I'm pretty sure it's the last one. Wait, those numbers are missing.
Huh?
That's what it is.
No, but it wouldn't work. Remember?
Put -2. You could put
When you plug in the
zero.
You put -2. Wait, no, you put 2. 2 minus
Then 2 times -2 squared. -2 squared.
Oh, wait. I'm wrong.
So yeah. Maybe. I don't know. Try plugging 2 in that thing. Yeah. In fact, that means I'll plug in 8 on it. Yes.
Oh, I
Maybe
just
2
didn't.
squared.
Because you put the 0 in, it's
gonna be like 6 zeros, right? Yeah, that's.
Wait, no, it's not.
I think it's the bottom. I think it's the bottom.
0 minus 1 is 1. No, it is. It's -2.
0 minus 1, so
No.
-1. It's the first one. Square.
So you have to cross. Alright. So if you put 0 in.
Wait. No, yeah, okay, it's positive and then, yeah. It's So that's It's not working like that. It's the first one. Golden.
Because
So yeah. Yeah, where did you get this? No. Wait.
What's 0 divided by 0?
But that's the point. Well, it does increase. But not by half until the
Yeah, not half.
Yes, because that's what it is.
1 hour, 60.
Yeah.
No, it's
The way we implement it, that would does not make sense.
No, because 60 minutes is an hour. I think it works for 60. Oh, wait, no, but it starts at 1. Okay, so yeah.
Oh!
I'm just gonna number.
It has to be 0. Oh, no. Right? Or is it less than? What?
That's fun.
Well, I think it's C2.
Yeah,
I think it's C.
No, because it starts at 1. You put 1, 1 left, 1 0.
But
So
at
it's
zero,
0,
so
it's at 1.
there's already an inch of water in it, so no, that can't be right.
Yeah, because we'd have to go plus 10 and it'd be like 4 points. Okay, so that's 1,000.
I
But
don't
if
think
you
it's
plug
just
in 4, but if you plug in 2
Now
now,
bucket as an outside for only 1 minute. Yeah, because there's already water.
And then the last one.
There's already water.
So 2 and
okay, and then you put 3. 3 minus 1 is 2.
I like these teams. Yeah, this is
Now Luke is 4. Yeah, like if I was to look, if you go to 3, 3 minus 1 is 2. The last one was, I know the last one was 8. But if you do this one, 3 minus 1 is 2. Yeah, because you put in 4. That's negative 9, 4 is negative 8. So it's 4. It's D, so easy.
she's the one for which each function is.
Damn, why did it take so long? I thought
Oh,
that was
no,
really
that's
hard.
Oh, there's 4. Oh,
Alright. Jared measures the body water in the
You
game. No?
Oh, it's like the.
How?
You have to, like,
You have to, your
it
end
has
has
to
to
be
be
on 0,
0.
but I think you have to, like, choose the ones that, like,
So
So your first number has to
so
be 0.
would be 0, right? -2 is 1, because that's like the first number. Then it goes, and so then it's
You're entering in 1, 2, 3,
What do you mean
4,
0
5.
would
So
be
this
zero?
is zero that count them, and if you get
I thought you can't
0,
use zero
-2,
as an end.
-8,
That's
-18,
why
and -2.
we got to start with 1
All those
as an end. Because it's greater than or equal to, and then that has to be
I would just
zero.
like the
yeah.
2 and 6, you just like that.
Jacob said to say it's probably
Is it with an A or is it
Is that what
A?
you're supposed to be
I'm going with
doing?
D, right?
I was going to be
Yeah, bro.
The first 5
What you said makes sense.
Well, but it's confusing because that's how you would set up the
You get
table.
0 for your answers when you enter
So
1.
if you just,
You get -2, -2,
But
-8.
if you
if you couldn't, you have like. Wait,
I'm
plugging one, what do you
I'm
get?
about to go to the next one.
I just didn't know that you only answered
Wait a
the
second.
answer.
Yeah.
But isn't it?
One squared
Put two
and
zero.
one is negative
It's supposed to be 0 though.
Minus
To be your
5 terms. The first 5 terms are 0, negative 2, negative 3,
I mean,
Or
if you
starting
just
out
put
as
I'm in
one,
first 3.
you don't get 0.
The first terms are 0.
Yeah.
Something that's not 0. Because the domain is all integers greater than 1.
You're saying-
I
10
don't-
or 16 plus 3 is 19.
This was called check over.
I think
That's what I thought too, but then like.
3 or 4.
We just said the first term.
16 plus 3 is
has to
18.
start with and.
So I mean
But don't you have
7.
to go up into the next term?
So I think that means 7 would be 28, right?
Yeah,
So 7 squared.
I'm not agreeing.
7
Exactly. So this is the end. Yeah. It's B.
Wait, which one's all the way integer
So like,
Yo, I would say
for negative 2, it's like I just went from 0, right? So you know it's in
I
negative
got
2,
D2,
1,
They say A,
and
so they're
the
Oh wait, it's
So
a
then you
squared
get-
sequence.
Oh, Jacob got D.
one squared is 1.
So this would be 2
Okay, can I explain
fours.
what I'm
So the
saying?
sequence would be
Okay.
1, 0, 1, 2, 4,
See, I
7,
don't know.
So the
28.
Your N has to be either greater or equal to 1, and if you start with 1 as an N for E, right? It'd be 0 to the second, which is 0, and negative 2 times 0 is 0, and that has to be your first term. And that doesn't work for this one. If you put the first term, if you put 1 times is equal.
Michaela, can you go send this to me?
Yeah, no.
That's what I'm saying. That's why A is not right, because this has to be
Front and back.
So it's going is 0, -2, -8, -18, -2, and that only works for D. If you start with N equals 1, it's greater than equal to. Besides that, let's put down a cell.
Well, that didn't get.
I feel like I'm going. I feel like it's D.
Yes, I'm on 4.
Okay.
I mean, yeah, that's what, which is either A or D.
So for this one?
Because I'm sure, that's all.
No, I chose A first too.
But then when Lucas like.
Okay, so put 1 in.
N has to be greater than or equal to.
But
That's
1
what
you get 4.
Because that's what.
But if I put 2 in, I get 5, not that one.
I use
No,
that
yeah.
as being like
The
just.
second one, if I put 1
No,
in,
yeah,
I
I know.
get 4.
I see, because
If I
I
put
did
2
that
in,
too.
I get 7.
Thank you.
If I put 3 in, I don't get 12.
Thanks for the thought.
You just keep putting the number in until you get the one that works.
I went on 2, bro.
I was hella. What?
They both.
Oh, yeah. Yeah.
Let's go. Sure. I thought you had a blue.
Yeah, I know that's right. Blue water in the bucket at different times during fall.
Alright, you're doing a great job.
The temperature each side is what
Yeah,
So one, temperature as low as temperature was decreasing.
So are we saying true or
was increasing? Yes.
3 inches per hour? So it's.
The temperature was equal to temperature peaking.
What's an hour?
Right, so okay,
So are we just doing this some serious out? for all my?
Just work on the bottom.
Okay then.
I will answer the question later.
I would know.
Oh, 3 is like the same thing. You don't have another place?
Everything is right except number 2.
There's 6?
Oh, so 3 times 3.
Oh, there isn't?
Oh, yeah, there is. 3 times
It's 5 divided by
Average number. So we have to do
Cool.
Take the
Alright.
largest and
Choose the domain in which each function is defined.
So
So I'm gonna have, so you have to put,
Okay. Was that a question going up there?
I'm not writing this
Number
out,
6.
I'm putting it on this.
Yeah, so now first off, notice, they want the temp per basket. Right? So they want to know for 34 baskets, right? Well, this is only going to get me 32. So I'm going to have to at least use that much. So I got like 15 in here.
Where am I put?
Over 6 baskets. Oh, no, it's a 10 per basket. That's times that.
Basic algebra.
What they're asking you to do is like the number of baskets, attempts per basket.
it's A over B.
Right, so it's A over B. And make the first 4 baskets. So to do the first 4 baskets, I really have to do that much every day. Because that only has
Super short, only 60.
5 minus 5 is 0. 5 minus 3 is 2. What does this have to equal?
that one.
No, 5.
You could kind of use the first 2 and say, well, I'm trying to find for the 4th basket. Well, not to say the first 4. I don't like that. That's my.
I don't either,
But the point I want you to see is, it's a temp over basket, not basket over temp.
Does this have to equal 0?
1, 2, 3.
So you got what you.
I don't know.
All right, you're doing great.
No numbers. Okay.
All right, you're doing great. Keep it up, please.
So it's C.
So, what are topics? Like,
Yeah.
what are
25
topics?
over 10.
I think it might be the last one.
7s, like the graph, that calculator.
Is that any
height,
equal
y,
or equal?
social, 24. Oh my god, I think that's it, bro. So it's not D, it's equal sign with the last. It's either here, so it's going to be
No one?
X out.
Okay,
Number 3.
Yeah, because it starts at its highest point and it goes to 24.
They want you to choose the domain. Remember, you cannot have 0 as a denominator.
I mean, yeah.
So the first one, the domain is
What happened here?
not equal to 6.
Mine died.
Then the second one not equal to 5.
Oh, I see what you're
The
doing.
third one, square root has to be positive.
Oh, I see.
So X minus 3 has to be bigger than 0.
Damn, all that was too much.
Consider 6.5 terms are.
So the third one, the X created with
Which is at its lowest.
and then the fourth one.
Lowest, like
1 plus 3 is 4.
and 2 is 3.
1 plus 3 is 5. Nope. A's out.
So it's going to be
What? Is that 1? So it's at 1 plus 3 is
Don't think
4.
about that too hard.
Is it going to be temperature on average?
4 plus 3 is 7.
So it's the temperature at
Yeah, I know, but like.
7 over 1.
They're all positive, so I don't understand.
730. 7. that was specific.
You guys would run to
No, it's not Oh, I see. Yeah, hardcore.
Sure?
Yeah, I'm not going after it's like, I feel like
They're all greater than one.
should be like,
That's like equal terms, bro. Yeah, it's like a, like if you make a box on Alright.
so it's temperature over.
Shit, I mean,
Because it's temperature per hour. See, so why do you do that? Degree Celsius. It's temperature.
that's how people talk,
Dude, we're becoming fancy kids, dude. We are hanging out with Parker.
75 like you.
That sounds kind of low.
2 hours.
Before we got off.
Yeah, it's good.
Determine whether each statement is true according to the graph, so whether true or false for each statement. Damn, bro.
Well, I'm pretty sure you and Ricky were at the same party for like 4 days.
Bro, literally.
You guys go to the court?
Exactly you look.
Because I think the soul is just like.
Jackie, did you want to go on the court? I got it. He's like,
I just told him the temperature reached its highest point during the experiment at hour 12. Definite. Will it hit? No, I know, but like, what's it called when it hits like a, what's that point called right there?
maximum.
Yeah, it's but like the temperature was at its lowest when the experiment began.
Why did you have to divide by all?
No, it was at 9. The temperature was decreasing for more hours than it was increasing during the experiment.
You guys didn't expect it from me, but they were both.
So it's decreasing all of here. Yes, we could count. So it starts. So it's from 3 to 9 is 6.
How much?
3 to 9 is 6. That's 9. 3 to 9 is 6. That's 9, and it's increasing from 3. Yeah, it's 9 to 6. Yeah, bruh. I just want to make sure it's 1 to 4. Okay, temperature at the beginning, or at the end of the experiment was equal to the temperature at the beginning of the experiment. Yeah. Uh-huh. What's that 3?
It's at 4.
It begins at 3 right here. Well, it's basketball. Records the number of attempts and takes her to make one. Attempts is A, basketball is B. Select the average number of attempts per basket. Do we just add them all up? Add both up and then just divide?
Look at the x-axis of this graph. Are you sure about that?
31. Keep that number in your head.
31.
Where do you see 32? I read that as a 30.
31, 15. 31,
So it's just 24 hours.
2.06.
I honestly have no clue.
Wait.
Oh, 6.
I just joking.
But isn't that?
That's what I said.
2.5.
I'm better at multi.
Wait, Lucas, what?
2.5. How?
Yeah, that's what I got with
Add up all of them and then average it.
You just divide it.
No, you don't, dude. It doesn't work. It says
Oh,
average.
great. I'm changing the value.
I just saw
So
this
the
24
value is
and I
the
said
right
it.
So what's the rate of change in the 2, 4, 6, 3? From base 0 to 0. There's it started
So you just add them all up and then divide?
5. So 5.
I have a project.
You have to add all of them up. Well, add them all the times, like 7, 8, 9, 1, 2, 3, 4.
That's my only way out, bro. Shit. That's why I play.
No,
I play with my mama.
Use my damn name. You know what I'm at.
I do add up an infinite amount of times. Magic. In fact, what is infinity divided by infinity?
Google Flex.
No, it's not.
Damn, bro. I wish I lived in Quincy just for that reason. You think Drew talks like that, man? I can't.
8 divided by 2.
The only reason I know it is my brother.
I'm about to start a point guard.
Oh, would
4,
you?
huh?
I'm so stuck.
I see 1 and I know 7. I added those and then I
Imagine if Zach was from Quincy, bro.
Wait, what did you do?
I don't know. I just
I don't think Zach was
Almost at the end.
I went
And then we go back and do
I
this.
went to 7:30.
Yeah.
Actually, I'm at Xbox.
But the way I'm doing this, I feel like it's just not good.
Why would you have to do that? No one
Like, you know what I'm saying?
Enter the rate of change.
Select the graph that correctly represents the height in feet and the rate of hour period based on the number of hours. Wait, what the fuck? Select the graph that correctly represents the height in feet.
Yeah, it's
on the ocean tide over 24 hours period based on the number of hours X that have passed since the tide was at its highest point.
Select the graph that correctly
Is this
represents
the
height of the rocket looking around.
So it's
It can't be A, right?
no, it's not C or D because I'm getting false or true.
So it has to start
Yeah,
It's not even an answer.
So I think it's
B, right?
Use your word
because
size.
it doesn't start at
Growth in
it goes backwards.
population.
Wait,
Right?
So I said.
would it not have to start at 0 though?
No.
Okay, let's stop for a
Wait,
minute.
so it's all true.
When did the first wave come? Did it start at 0 or did it?
And
Yeah, what if
population
it's-
is
Are you guys on the tide?
that
Yeah.
Yeah.
Okay, let's stop for a minute. Go ahead and put your computers away.
I'm gonna laugh and put it in.
Oh, cool, you answered my
I'm gonna
question.
put secret.
So this is going to be part of your homework. I'm going to want to look at your answers at the beginning of the period Wednesday. And then we're going to talk about a couple of the problems. Now, of all the problems I've seen so far, the tide one is that's a dependent on knowledge problem, so that to me is kind of a word test question for a math test. Now, I'll tell you the tides, there's 2 highs and 2 lows in a 24-hour period. So when you go back and look at those graphs, keep that in mind, okay? 2 highs, 2 lows. Jacob, do you have a question?
No.
You were going to tell me that?
I was actually just gonna say that you can rule out like half the graph.
Yeah, you can. By, and hear what Jacob's saying, a lot of these problems you can rule out information by. We're going to talk about that a little bit on Wednesday too. Okay, so now let's go, turn that guy on. I asked you to do some homework, so can you get that out?
And you would actually
I'm shit, bro. Nah, bro, this is my mom.
I was just really bored, so I thought I'd do one.
Oh, we're talking about that.
Yeah.
Dang it.
You're supposed to do both of them.
Dang it, I wanted to.
Oh, we left at
Wait,
11.
So you did good for
Heck.
I mean, I looked
Oh, I
at
might have
the
did
video.
it. Rap.
Shit, I come from project though. I went from my mama. You know, I didn't even know I played basketball.
But I already know what grass I
You ain't, some of you ain't here Friday, but again, the video explained the homework.
I'm like, man, in this shit.
You're supposed to put the clothes on.
see it back. Oh, I didn't do basket, but I wait a second. Are you sure about that? Okay.
All right,
Shouldn't the graphs be peeking at the
let me do this.
Wait, no.
Just a quick minute.
How does the graph go?
Because when times at the high.
Plug in like 100 sine. That's like or sine. Yeah, like 100 sine equals negative.
No, you're gonna mess it up.
Yeah, just plug it into the calculator, buddy. Yeah, just plug it in.
That confused me for a second.
That's
You did your, I did mine one away from the top. You did yours like this.
Yeah.
I was just like,
All right, who else has
How
to
does this
add?
graph not align with this?
You did.
We're supposed to do two
That's part in class? Did you do that at home?
I have one month.
Ricky, where's your paper at?
I did the work, but I didn't.
Yeah.
Like 90.
All right, so I'll give those who really went and finished the graph part a little bit extra credit. The rest of you, that is part of the homework, you do need to do it. I am going to talk about it right now and have you get you jump started on it. And so what we do Friday, well, one of the things we did Friday, I'm trying to get back to here in time. One of the things we did Friday was we started talking about some graphs. And we filled in this chart
Yeah,
here.
probably.
Okay. So what did I draw on Friday? I drew what kind of circle? What kind of circle did I draw on Friday?
A round circle?
Around one.
It was round, that is true.
Was it a unit circle?
And then you had a radius of 1.
And Jacob's saying it's a unit circle. Now what's he mean by a unit circle?
With a radius of 1.
Right, so we drew a circle with a radius of 1 here, right? That makes sense? Okay, radius of 1. And then what? Well, we went and calculated, this is 10 degrees here, right? That makes sense?
Yeah.
Okay, so that's 10 degrees, right? So especially for those who weren't here Friday, calculate the x and the y right now. There's my x and there's my y. Okay.
Did we do this last year? Like, Z graph?
Yeah. This is a different
All right,
way.
let's do the calculation. And then do it for 20 degrees. All right, and then do it again for 20 degrees. ended up getting 0.34 and 0.94 for 20 degrees, right? Now notice, what's really happening here is I'm saying, oh, the cosine of 20 degrees is equal to the x over the hypotenuse, right? That make sense? See that?
Yeah.
See what I did though? By making the hypotenuse 1, right? The x and the cosine are the same.
Yeah.
By making the hypotenuse 1, the x and the cosine are the same. That's the real point I want you to recognize. So, on the unit circle, I think I said this Friday, but I'm going to say it real loud now. On the unit circle, the cosine of the angle and the x coordinate are the same. We can say the same thing for the sine of the angle and the y coordinate. Are the same. Okay? I want you to really get this in your head. This is the concept right here in a lot of ways. The cosine of the angle and the x coordinate are the same. The sine of the angle and the y coordinate are the same. All right? And so for those of you who weren't here, you need to go build a chart. At 10 degrees, so this is the angle. At 10 degrees, the x is what? 0.98. The y is 0.17. At 20 degrees, the x is 0.94. The y is 0.34. At 30 degrees, the x is 0.86. And the y is 0.5. Okay, 40 degrees, the x is what? I don't remember that one.
76.
0.76?
Yeah.
Yeah.
And then the y is
0.64.
0.64?
Yeah.
And then what happens?
It switches.
And then what happens?
There's a bunch of little kids over.
They do be going hard though.
Okay, and then what happens if you notice, here's the thing to notice. Let's take 20 degrees in this direction, right? And then I decide to do 70 degrees. Well, that's 20 there. Go stare at this. The x and the y's just flip. Because this 20 is this 70 here. So what happens is these two values just flip. So 50 for the sine is the same as what?
Sine.
40 for the cosine. So at 50 degrees, I just flip these. 60 degrees, I flip. Alright?
0.5.
At 60 degrees, let's see, so 0.5, 0.86, 70 degrees, 0.34, 0.94, 80 degrees, 0.17, 0.98, and then 90 degrees.
0, 1.
Right, because we're at the top. Okay, that makes sense?
Hopefully the zero crease that part.
Now, for those who've gotten this, you can see the struggle here. Some of you is like, I can't pay attention because I've been through it. And then some of you, I'm kind of trying to do this fast, so I'm burying some of you at the same time. So there's this is the struggle with having classes with students. That's your fault. It creates a struggle. Okay, now what's going to happen at 100 degrees? Well, 100 degrees, I'm right here.
So
That's kind of like looking at that as 10 degrees, right?
Yeah.
So that's the sine part over there and the cosine part's right here. So the 100 degrees, we're right back to doing the x and y down here at 80 degrees. The x is negative 0.17 now. And the y is 0.98. So now it's just negative 0.17 and the y is 0.98.
So what happens is it starts from the versus.
Okay. Hey, let me draw this a little differently. I hear you. Thanks, James, for trying to explain this. If we draw the 80, there's the 80, right? And notice, that's the x part really right there, that little line. And then that line's the y part, right? Now when I go to 100 degrees, I'm really going to right there, right? And notice that these are both the 10s in here. So really these two triangles are the same. Only the x is negative now. You see? So you end up walking back down this chart kind of backwards again. So at 110 degrees, it becomes 0.34, negative 0.94. 120 degrees becomes 0.5, 0.86. Clear down to...
Are they both negative once you get under 180?
Right, so once you get below 180 in this part, they're both negative.
Okay, and then and then past 270, it's the other way around.
Then the x is positive and the y is
okay.
negative.
Yeah.
You see how this chart works?
Yeah.
Second.
Realistically, you only have to memorize about 4 values and then you can fill out the entire.
Right, that's right.
Good.
That's it. 8 values, basically.
Yeah.
Well, no, because at 40 it will switch.
Well, yeah, but you gotta have those.
Oh, well, yeah, okay, good point.
All right, nitpicking, but yeah, 8 values, 4 points, 8 values, right. Once you have that, you have this whole thing all the way around, right? Okay, now, here's the cool part. So, what we're going to do now is what I have here is 3 things. I can't really graph 3 things. I have an angle, an x, and a y, right? So what we're going to do is graph a relationship between the angle and the y. I'm going to let the angle be the domain. In other words, for this angle, I get that y, right? See what I mean? And hence for that angle, I get that y. And so this is part of the homework I want you to go finish. I'm going to get you started. I want you to finish the chart and finish these 2 graphs, please. Because this, eventually you're going to see for one hell of a lot of physics out there. This is the backbone of the math. Okay? I don't want to let too much of the cat out of the bag yet, but for one hell of a lot of physics, this is the backbone. So if you're going to go do any kind of electricity, any kind of engineering, you're going to see what we're going to do here pretty quick, all over the place. So we're going to graph it. And there's some graph paper like this in the corner over there on the chain. Go get yourself some if you don't have one of these.
That's just dumb screen. Yeah, that one I would even have big project. You have the whole
Yeah. No, I don't. Once you got the first. She just Coach Yumi looked at each other, we're just like. Two?
Why so enthusiastic? The corpse.
That's just
Thanks, Jay. Thanks, Jay, for not forgetting up and showing that cursor code. I bet.
Okay, you ready? Now, what are you looking at here is we're looking at numbers that go from 0 to 90, right? Or actually 360, because we're going to do 180 and so forth. All right, everybody pay attention. And then these numbers are between what? 0 and, or 1 actually, we get put down there, that's 0 and 1, or 0 and negative 1. So what I'm going to do is, this is point 1, point 2, point 3, point 4, point 5, 6, 7, 8, 9, there's 1. Okay, because I'm doing the y is the y-axis at the moment. Understand? And then these guys are going to be degrees. I'm going to put 1, but 1 stands for 10 degrees. Thank you. So 10, 20, 30, 40, 50, 70, 80, there's 90 degrees. 100, 110, 20, 30, 50, 60, 70, there's 180 degrees, and so forth. You're going to curve across.
Oh.
Okay, see? So we're going 10, 20, 30 degrees. We're going from degrees to the y guys.
Okay.
So at 0 degrees, who's the y? Right, because we're on the x-axis. So at 0 degrees, the y is 0. And then you're going to get a fairly accurate graph. At 10 degrees, I'm at 0.17. So at 10 degrees, there's about 0.17. And then at 20 degrees, you're going to be at 0.34. So here's 20, 0.1, 0.3. There's about 0.34. 30 degrees, I'm at a half. All right. And this is the graph. So you're going to do this twice. You can do it on the same one. The first one you're doing is theta to y. And then the second one you're doing is theta to x. Okay? That make sense? And I'd like you to, if you haven't done this, to complete it. I'll show you what it looks like. This is a very nice job done right here. So you can see the first one right here, going up, hitting the 1, coming down, going through his 180, coming down, and then we didn't have enough to go clear out to 360. But we come down and go up like that. Alright? I want you to work through this and do both of them. Yeah. Okay. So, let's roughly talk about this now for a minute. You're to go finish that later, please. But here's what I want you to recognize. So 90, 180, 270, 360. All right, come on, in the back, pay attention. You can finish later. Okay. 90, you're at 1, right? So it's kind of like, notice again my axes. The units aren't the same. I'm calling that 90 on the x, and I'm calling that 1 on the y, right? See what I'm saying? And hence this guy goes up to 90, back down to 0 to 180, goes down to -1 at 270, and back to 0 at 360. What happens when I add, what's 360 and 90? 450, right? What happens at 450? I'm going around the circle again, and I'm back up at 1. This is the graph of angle to the y part, right?
Yeah.
You want to remember what in the blank is going on. This is the graph of angle to y.
Didn't the shadow, remember when you did the shadow thing, wasn't that like the same graph?
That's the shadow. I did the shadow thing. I did the shadow thing. We're going to talk about it. There's something going back and forth, like the shadow. In other words, if the circle, the shadow, the same motion as this part. You can say yes, but I can go find all kinds of functions and go back and forth. Proving the motion of the shadow is the same as the card. Again. But Enrique is very correct. Let's go back over that again. What we're really graphing is the shadow. Starts right over here. All right? So I'm graphing the shadow. You paying attention or not? 80% paying attention right now. I'm graphing the shadow. So I'm starting right here. I'm graphing the y shadow. Because I'm starting at 0 in the wall over here, right? You see this? As it goes around, it's going back and forth. See this another way? There's my circle down here. Right? I'm starting here, means for the y is what? 0. Then I've gone up 10 degrees. So the y has gone up a little bit. So at 10 degrees, we're up to there. Okay? So we're graphing the shadow, and if I start it over here, if I start my shadow over here, we're doing the y graph. If I start my shadow up here, you're doing the x one. What you're going to discover, which is the one you did, here's the x one. And the same graph, just shifted. Alright, you see what I'm saying? Here's the x one. I'm starting here. I'm coming down. And then I'm going around, coming back up. Okay. I'm going to live in this land for a little while. Everything about sound, we talk about sound, everything about light, everything about that spring, anything that vibrates. These two graphs are the base of all of it. Some of you probably know we call the first graph the sine of theta. It was built from the sine values, wasn't it? It was built from the sine values. And the second graph is cosine of theta. All right? What's the periods of my graphs? How long does it take to do one cycle? How long this guy here is watching? He's up to 1, 0, -1, 0.
Okay, good point.
4 periods.
Takes 360 degrees to go through one. Takes 360 degrees to go around the circle once, right? So as I go around the circle, what am I doing? I'm doing it again. As I swim around the circle, I'm swimming again. I just swim. What's this graph do? Okay, I'm going to show this in physics again. Think about the wave as a graph of time. Now, the wave as a graph of time. What's the wave as a graph of time? The wave over time is doing this, right? But I'm going to make the x-axis the time, right? So what am I? I'm going to walk. So my walk is the time. Think about it. My move. If the x-axis is the time, right? My moving in this direction is this time part, right? See what I'm saying? The wave's bouncing up and down. So the wave's bouncing up and down, and I start walking. This is the graph of the wave as a function of what? Time. We just graphed it as a function of the angle on the circle. They're the same. If you really get that, which you don't right now, then you're going to be some farther along understanding. This one is what? When I put it into an angle, what am I thinking about? I'm thinking about going around the circle, and I'm looking at the y part that's going up and down like that. I can put my y over here, right? My y part that's going up and down. When I take my walk, I took my walk here, I'm looking at a spring going back and forth over time. And the graphs look the same. That was the wisdom of 500 years ago. And then Laplace and Fourier took that wisdom and melted it. Fourier basically took this concept to an unimaginable level, trying to answer this question. When I heat a metal bar, say, put a candle in the middle of a metal bar, how fast does the heat move through the bar? And the heat melt all of that to make an answer. Yeah, what the hell is heat moving like that have to do with things moving back and forth? It was an incredible amount of mathematics when he was done, and everybody went, whoa. He just answered everything about vibration, whether it's waves, sound, anything. And the reason I'm telling you that story, the bottom line is, sometimes, most of the time in science, when they're looking for an answer over here, he's looking for an answer for how fast heat's moving. And he ends up creating a whole nother field that nobody knew. That answers all these questions over here. Science is kind of a bouncing game. We get it, or they get it. I'm not a scientist. Sometimes they do, and sometimes they don't. Okay. So let's regroup for a minute. Then I think I'm just going to let you go. There's not enough to really go forward. So I want you to be able to roughly graph the sine of the angle, recognize this period is 360 degrees, okay? And the same thing for the cosine. Be able to roughly graph it. What's a rough graph? Well, you come down here and you make 4 clicks. Okay, I'm going to make a quick graph of the sine. So I make 4 clicks. Who's this guy? That's 360 right now, right? And hence 180, 90, 270. That's 1 there, 0, -1. Boom. You're done. Be able to do that in your sleep. And then the cosine. Well, the cosine, same clicks. You try it here, 0, -1, 0, 1. Boom. That's the cosine. All right. Okay. All right, let's do this. Be in this book. Okay, what homework we on?
Safety.
Okay, 4C, right? Okay. 4C. Here's what I'm going to do. 4C is going to be a few book problems. I want the questions I gave you finished by Wednesday on a separate sheet of paper, okay? That thing and those guys. And then 4C, I'll put some problems up on the board or in the book. In chapter 9, let's just start now. Chapter 9, I want you to do 13. 13 through 17 in the book.
What's chapter 9?
Chapter 9. And there's books over there, so you can either work on the book problems or work on your thing for the rest of the period. Okay? All right.
Yeah, you want to work on the third side.
Okay.
It shouldn't be hard. I just can't.
No, the first one.
Oh, okay.
I understand the whole domain thing.
Okay. You just, so the sign, you just gotta know the ranges.
And I have islands in here.
And this
Now
one,
zero.
right.
And I understand.
Okay. So on this one,
No.
I just know my answer has to be somewhere in here.
Yeah.
And the cosine, so in other words, on the circle, if we look at 5 pi over 6, right? Then that one is the negative square root of 3 over 2.
He was easily the best player, bro.
We're over here, pi over 6. This is the square root of 3 over 2. So, it's kind of like, this is the answer that lives in this. So there you go. In other words,
over a 10-week period.
let's do the cosine inverse of 1/2. Or the cosine inverse of 1/2 is pi over 3.
So 14 is like pressure
The
falls.
cosine inverse and negative 1/2 is 2 pi. Because I'm here. So I'm only
So
doing,
on this one, on the sine inverse.
right, it's going to be down here now, right? So it's down here at this one. So that's negative pi over.
It's just we screw.
Oh.
this is flip
That's
side.
what it was.
So these are
See, I keep
negative,
getting
right?
confused with that.
Yeah, because these are negative, you keep looking for negatives in the cosines, I think.
No, I just keep, I keep thinking of it as like this circle.
Oh,
already
right.
have an line. I think of it as this part.
Right,
But I
right.
don't think about it as just using this as 0 and then going backwards.
Right,
If
okay.
that makes any sense.
Right, that makes sense. You gotta remember
And that's
those
why I
are
keep
going,
messing up.
right. Okay, I get it, you see it.
Yeah, and I saw it before, I just keep forgetting, so maybe this time.
Okay, perfect.
So basically, it goes up by none, it goes up by 1, by 1, by 1, by 2, and by 4. So definitely not 0.7.
It's not there, always
Well,
has to be.
yeah, no, it's not 0.7. It's
Number
no way.
at 0. It could be any number.
Zero means like-
Yeah, this one can't be 3. I want it to be like 3 touching because it's something. And this one's 5, can't be 0. 5 is 0. Yeah, it's 5 minus 5. Yeah, I think it's this one. If X can be greater than 3.
Greater exceeds equivalent of 1 stages.
And this one X can be greater than 3. What if we get this done by Wednesday, though?
Maybe you do
Just whatever.
Is that 9?
Nah, bro. No, this has to be done by Wednesday also, as well as the worksheet.
27. I think it's 27 for some weeks. Yeah.
Yo, Zach. What'd you get for your son?
So it goes 1 true, 2 false, 3 cannot be determined. You gotta go back to 3. Yeah.
Things of coffee.
1 that this is not good.
Only drink coffee.
Me too, bro.
So bad.
We're all just like, you just gotta do it. You just gotta do it.
Whatever.
What did you say?
It's whatever.
I didn't even
X
know
is
what you
making.
said. Full set. Like, what do you mean? Oh, is it?
You good?
What?
Oh, it's not.
We're not doing this, bro. I'm trying to do this.
Does it go like that?
That's easier than this.
What? Like, does this one correspond to this one, and this one corresponds to this one?
Yes.
Oh,
If you go,
okay.
that's
I
what
got homework.
James. What?
Have you,
Oh, I thought you.
have you done these problems? Have you seen them?
No.
Missy, what do you want?
I'm so confused on this problem.
I'm on 9.
Which one?
3?
I think silent numbers like that.
Yeah, I don't have to do anything.
So I don't like write on the page again.
Like,
I do a brick, dude.
It's just.
This one.
how have you done? How have you always done? Or unless this is them.
Okay, natural max equals.
Oh.
Okay, I don't
The
like, I
equals
understand
five.
what it's saying, kind of. I don't know that. That's X.
What is
The
that?
answer is
Right?
5.
It's a body. So,
Is that a penis?
so then it could be anything but
Like,
that.
what do you mean?
That's what I understand.
Because then it's just like a negative, it's like, you can't do anything in the middle, and the graph can go both ways. Wait, oh, wait, no, it's an X over minus 3, so so it'll go like one direction.
Do the same thing as do number 3.
Oh, it's a face.
Yeah, you can see.